think of when you hear the word median? John?
Middle.
Very good, middle. So the medians involve something regarding the middle. And what do you think of when you think of altitude?
Height.
Yeah, how high you are. It's going to involve the height of a triangle, okay? So let's start with the median of a triangle. The median of a triangle is a segment from a vertex to the midpoint of the opposite side. Every triangle has 3 medians, and the medians are concurrent, not congruent. People confuse those. What does concurrent mean? It doesn't mean congruent. Good. What does concurrent mean? It was in 6.1. John?
Non-occurring?
No.
Like it doesn't
Yeah.
go opposite ways?
No. We covered this earlier. Yes. Kind of. It's when 3 or more lines all intersect at the same point. So your 3 medians that you're going to draw on this triangle should all intersect at the same point. Let's get some practice drawing medians. So do you see how CD, that is our median, it cuts AB into 2 equal parts? Because it goes through the midpoint. Do you guys agree? So approximate, you're not going to be perfect, okay? But try your best to find the midpoint of CB and connect that midpoint, go across the triangle to A. Go ahead and do so now. Try to locate the midpoint. Do as best as you can. It's not going to be perfect because we're not using rulers. But try to find the midpoint of CB and draw a line across the triangle to point A. You just drew a median, okay? As long as it goes from a midpoint to a vertex. You guys cool with that? Okay. Do the same thing for the side CA. So approximate the midpoint and then draw a line going through that midpoint across the triangle to B. If you did it correctly, yours will probably be a little bit better than mine because you guys can draw perfect lines of notability. Does it appear like they all intersect at the same point?
Yeah.
Very good. Put a dot there. That is the new point of concurrency. So we know circumcenters, we know incenters. This point is called your centroid, okay? Now, I want you guys to relate like each of these points of concurrency as like having a superpower, right? Circumcenter's superpower was it was the same distance from all the vertices, right? Incenter's superpower was it was the same distance from all the sides. A centroid's superpower is it's the center of gravity of the triangle. So if you took like a pencil, right? And you place that triangle on top of that pencil, the only way the triangle would be balanced is if the tip of the pencil was touching the centroid, okay? It's basically where the triangle has the most balance, the center of gravity of the triangle, okay? Now, some other things you guys need to know about the centroid is it's always inside the triangle. What else is always inside the triangle? Cody? The incenter. So both of those 2 points of concurrency share that property, that they both must always be inside the triangle. Any questions right now in regards to a centroid? So if in a word problem it asks you to find the center of gravity or where a triangle would be balanced, what point are you going to try to find? The centroid, okay? Now, another property about the centroid is that when you connect all of the medians and you locate that centroid, it divides each of the medians into 2 parts. And the 2 parts are proportional by 1/3 and 2/3, okay? So, all 3 of those segments that are drawn in blue are your medians, and they meet at the point P. That means P is our centroid, okay? Now, it divides, I want you guys to look at, we're just going to look at one of the medians. We're going to look at BF, okay? It takes BF and it divides it into 2 parts. It divides it into BP, right? And PF. Do you guys see that? How BF is in 2 parts? Okay. The larger of the two parts is exactly 2/3 of the whole segment. So BP is the equivalent of 2/3 of BF. It's 2/3 the length of the entire thing. And if BP is 2/3, what do you guys think PF would be? 1/3 the length of the whole thing. Okay? Now, let's do the same thing. Change the color that you're writing with so you can see the difference. Let's do it for DC. So DC is also a median. It goes from a midpoint to a vertex. How do you think we could write what DP is equal to? DP. It's going to be 1/3. Why is it 1/3 and not 2/3? It's the smaller segment. Very good. So it's 1/3 of what? DC, the whole thing. Okay? And then PC would be what? 2/3 the length of the whole thing. DC. Very good. Okay? And then lastly, use a different color for the last piece. We're going to do AE as a median. AE is separated into two parts. AP is the larger or the smaller segment? It's the larger one. So we're going to say that AP is 2/3 the length of, did I say AE? AP is 2/3 the length of AE. And PE would then be what? 1/3 the length of AE. Yes, Diana.
So the biggest line is 2/3 and the shortest line is 1/3.
Very good. That's a good way to think of it. Did you guys hear what Diana just said?
Is there
The bigger of the two pieces is always 2/3. The smaller of the two pieces is always 1/3. Go ahead, Sophia.
is there never is there not going to be a number in the one next to AF?
AF. Oh, is AF, could AF be a number?
Yeah.
Absolutely. So check this out, guys. What if AF was 5? AF is part of the side. Do you guys agree? So it doesn't get applied to the centroid problem, right? It doesn't apply to the centroid theorem. But what else would then have to be 5? FC, because isn't F the midpoint of that side? Good observation, Sophia. Okay, so if it does give you AF, you now know some information. Do we know what AC is as well? AC has to be 10 because you're adding up both of those pieces. Does that make sense? Okay, let's problem. Go to the next slide. It says in the triangle, S is the centroid. Perfect. So we are already given that this is the centroid. We now know that we have proportions of these segments. So SP is a smaller one, RS is a smaller one, and SQ is a smaller one. Okay? It says that RL is 21. So let's go ahead and put that on our diagram. It says that this distance from here all the way down to here is 21 units. Let's just do that part first. Could we find LS? If RL is 21, could we find LS? Juliet?
Yes.
Absolutely. Go ahead.
RS looks about 1/3. SL looks about 2/3. Divide 21 by 3 times 2 plus 7 plus 7 is SL.
Okay, perfect. But let's take it one step at a time. Okay. So you guys agree that LS is how much in regards to RL? 2/3. So let's write that in there. It's going to be 2/3 whatever RL is, correct? So we can write, why am I writing RS? Oops, let's erase this. We should write LS is equal to 2/3 RL. Cool with that? Okay. Now what Juliet was saying, she's saying, okay, well we already know that RL is how much? 21. So plug that in for RL here. We're going to get LS is 2/3 of 21. Is 21 divisible by 3? Then divide it by 3 and you get what? 7. So now we're really just doing 2 times 7, which is 14. So we know that LS is 14. Now, watch. Some cool things are going to happen. LS is 14. What would RQ have to be, Nick? What would RQ have to be, Juliet? 7. Why?
Because they're the same length.
What's the same lengths?
RL is going to be the same as QN, so RS is going to be the same as QN. Shouldn't it be R?
Whoa. No. We cannot, okay, hold on. We cannot relate this median with this one, okay? It's all part of the same thing. But if we know that this piece is 14 and this piece was 21, the whole thing, right? How do we find this missing piece?
7. It's 7.
You just do 21 minus 14, correct? Which would be 7, okay? I said RQ? My bad. I meant RS. Sorry. Okay, RS needs to be 7. Also, isn't 21 divided by 3 7? So you guys agree that RS is 1/3 the length of the whole thing? Okay, one more observation. These will always be a half or double each other. So you see how this one's 7? 7 times 2 gives you 14. So the larger segment will always be double whatever the smaller one is. That's the way that you can check that you got it right. Any questions on this first example? Okay, let's do the opposite now, where we know what SQ is, and we need to find the median, the length of the median, okay? All right, so in the second example, I'm going to erase some stuff so I have some room to write. We're given that SQ is what? What did it say? 4? Okay, so if this piece is 4, right? We know that SQ should be related to the whole thing how? It's 1/3 of what?
SQ is a third of
NQ, perfect. And if SQ, we're going to replace it with 4, right? It would be 4 equals 1/3 NQ. Could we solve this equation for NQ? Could we solve this equation for NQ, Grayson?
Yes.
Yeah, how?
We'll just multiply 4 times 3 and get 12.
Multiply both sides by 3, and you would get 12 equals NQ. So the length of the entire thing is 12. Now watch, I told you that the smaller segment is always half the larger piece, right? What's 8 times 2? Or excuse me, what's 4 times 2? 8. And if these were 8 and 4, don't they add up to give you 12? Okay, that's how we check it. Any questions on this first example that I gave you? The only reason we knew it was 2/3 and 1/3 is because S was what kind of a point? Centroid, okay? So anytime you see centroid, you're automatically given some information. All right, next slide. A sculptor is shaping a triangular piece of iron that will balance on the point of a cone. At what coordinates will the triangular region balance? So what point are we looking for? A circumcenter, an incenter, or a centroid? Centroid, but why? What about this problem tells us we're looking for a centroid? Grayson? Very good. Underline that word balance. What's the superpower of a centroid? German? No. What's the superpower of a centroid? What's its superpower? John?
Can balance?
Yeah, it has balance there because it's the what? Center of gravity, okay? The center of gravity is at the centroid. So, the centroid, go ahead, is the midpoint to each of the vertices, right? So guess what we have to find? The midpoint of each of the sides. So let's take this side over on the left first. Let's do this one first. And let's find the midpoint. You would add what? 6 and 8. X1 and X2. And then we would divide it by what? 2. Then you would take 6 and 2 and do what with them? 6 and 2, you would add them and then divide by 2. We're going to get that our midpoint is at what point? 7, 4. Put it on your graph and eyeball it. Does it look to be about the middle of that segment? Perfect. Now, to find a centroid, you have to draw all of your medians. This point, I'm going to connect it with what other point? I heard 10, 7. Who said that? Very good. Why 10, 7? Why does it need to go to 10, 7? You're absolutely right. Okay, it is where an angle of the triangle is. Guys, it needs to connect to a vertex, okay? And if we connected it here, would that be going across the triangle? No, it would just be part of the side. If we connected it here, it would just be along the side. Do you guys agree? So think about it, it has to go through your triangle to the opposite vertex. Do you guys see that now? Okay, let's do another side. Bryson, can you help me find the vertex of, no, not the vertex, the midpoint of this side?
Yeah.
Walk me through it.
So you could do 10 plus 8
10 plus 8
over 2.
over 2.
And then 7 plus 2 over 2.
Perfect.
And on the left, that would be 18 divided by 2, which is 9. And then on the right, it's 9 divided by 2, which is 4.5.
Yeah, 4.5 or 4.5. Perfect. So our midpoint is going to be at 9, 4.5. Don't freak out because we got a fraction. Just try to go right in the middle of 4 and 5 on the y-axis. You should get your midpoint is right around here. Bryson, would you say you did a good job with the midpoint? Does it appear to be equal on both sides?
Yeah.
I would agree with you, okay? Where does that point need to get connected to now? Cody? 6, 6. Perfect. Now, you can already see where our centroid's going to be. Do you guys agree? The third side is just going to be for insurance. Like, I know I got this right. Does that make sense? You don't actually have to do the third side because you're guaranteed that these 3 lines are concurrent, right? They must intersect at the same point. But let's just do it just to be happy with ourselves. Who would like to calculate the midpoint of the last side for me? Nick, could you do it?
You can do 10 plus 6 over 2,
Mm-hmm.
7 plus 6 over 2.
Yep.
10 plus 6 equals 16 divided by 2 is 8.
So it's 8,
6.2 because 7 plus 6 equals 13 divided by 2 is 6.5.
Good. So it's 8. Oops. It's 8, 6.5. Very good, Nick. Thank you. So we go to 8, 6.5. That's right here. And where do we connect this point to? 8, 2. Have we ensured that they all intersect at the same point? Yes? What is the point? 8, 5. So in order for this guy to have balance in his triangle, he needs to utilize the point 8, 5, because that was what in regards to the triangle? The centroid. Okay? Go ahead. Any questions on this example? Guys, did we need to use slope at all in this problem? No, okay? We use slope for perpendicular bisectors only. Understood? Okay. Moving on, let's do another one. Example 2, okay? There are 3 paths through a triangular park. Each path goes from the midpoint of one edge to the opposite corner. The paths meet at point P. What is point P? What kind of concurrency point? It's the centroid. Does anyone know why P is the centroid? John?
Because 2 lines intersect. 3 more lines intersect.
3 or more lines intersect there, but how do I know it's not the incenter or the circumcenter? What about the instructions of this problem? Kristen?
It says that each midpoint goes to the opposite center.
Good. Midpoint of one edge to the opposite corner. That automatically tells me, okay, this is a centroid. Does that make sense?
How does it tell you that?
How does it tell you that?
Yeah.
Well, that's the definition of a centroid, right? It must go from a midpoint to the opposite corner or the opposite vertex of the triangle. Does that make sense? Okay. So now we're given SC. We're told that SC is 2,100 feet. And that's really hard to draw. There we go. That's better. 2,100 feet. How could we find PS and PC? Go ahead. Divide by 3. If I divide this by 3, what will that give me? SP or PC? SP will be 1/3 of 2,100. Very good, okay? Because that's the smaller of the two pieces. Do you guys agree with that? What is 1/3 of 2,100? 700. So SP must be 700. Then what is PC? 1,400, okay? You can either calculate the 1,400 by taking 2,100 and subtracting 700, or doing 700 and multiplying it by 2. Do you guys agree? Any questions on that segment? This second one is designed to trick you. Why would the second one be designed to trick you? Where is BT? It's on the outside of the triangle. So is it part of a median? No, it's part of what? The side. It's part of the side. So I want you to put BT is 1,000 feet. Put 1,000 up there. What would TC then have to be? 1,000. Why? Because T is the midpoint of the side. Do you guys see that? Because remember, if that point is a centroid, right, then anytime these medians touch a side, it's cutting it in half. Do you guys agree? So then what would the length of BC have to be? 2,000. BC would have to be 2,000. How many of us, before I did this problem with us, would have fallen for that trap? Be honest. No one? Okay. All right, last example, I promise, okay? We're going to find PA and TA when PT is 800 feet. So PT is going to be 800. How could we find AP or AT? Cody? Good. You're just going to do 800, multiply it by 2, and we would get 1,600. And for AT, you can add them together. Yep. Or take 800, multiply it by 3. And we would get, I believe, 2,400. Perfect. It's a little bit slow while it's loading, but there you go. So AT is 2,400, AP is 1,600. Okay, we are going to slowly introduce this to you guys. So I'm going to save the fourth point of concurrency for next week on Tuesday. Listen carefully. Your big ideas is all together. Do not do any problems this weekend that involve an altitude or an orthocenter, okay? We didn't cover it. Only do the problems that involve what? Centroid and what segments? Medians, okay? Only do those problems. Turn in these notes. It's also called the height. So go ahead and write a little note to yourself. This is also the height of a triangle, okay? It starts at the top vertex and it's a perpendicular line down to the base, okay? In other words, it's starting from a vertex to the line containing the opposite side. That opposite side is going to become your base. How I do these problems is I have to rotate my iPad because I'm a very visual person so that each of the new sides becomes my base, okay? So take a look at the first example, right? We're going to do PQR. We're going to draw all three of its altitudes because each triangle has a different altitude because there's three sides. Each of the sides can be your base. So looking at this triangle, PQR, which side is being used as our base here? Yep. PR, right? So PR is our base. Start at Q, and do you guys see how they're drawing a perpendicular segment down to the base of the triangle? Okay, what you're gonna have to do is pull down the right corner of your iPad. You have to lock your screen to do this because we're gonna be rotating our iPads so that we can see where all of the altitudes are coming from, okay? So lock your screen so when you rotate it doesn't change. And I want you to put QP as your base. So have QP be the bottom of your iPad, okay? So you're gonna rotate it so it looks like this. So now your altitude, you're gonna start at what vertex? What vertex is not part of our base? R. So put a dot at R, and to the best of your abilities, it's not gonna be perfect, draw a perpendicular segment to what side? QP, which is your base, okay? So to the best of your abilities, draw a perpendicular segment down to QP. That is another altitude, right, of this triangle, okay? Then turn it so that QR becomes your base and P becomes your vertex, your top vertex. Start at point P and do the same thing. Draw a 90-degree angle with the base. And if you did it correctly, they should all approximately intersect near the same point. Do you guys see that? Yours was off? It's, oh, yours was way off, okay? So yours, that doesn't look perpendicular to me. I think it needs to be more towards the right, okay? Check yourself. If you drew perfect perpendicular segments, they will all intersect at the same point. We are not perfect though, okay? There's no way for us, unless we use an actual protractor, to draw that 90-degree segment. So as long as it's close, I'm happy. But if you're way off, draw them again. For acute triangles, all of our altitudes were inside the triangle. Do you guys see that? Just take a look at this triangle. Remember, the triangle is in black. What kind of triangle is this? It's obtuse because of this angle. Do you guys see that? That angle is larger than what? 90. So it becomes an obtuse triangle. Our altitude is therefore where? Outside the triangle. Do you guys see that? So when you have an obtuse triangle, your altitudes can be outside. When it's a right triangle, your altitudes can be on the triangle. Okay? Now, where those altitudes intersect is something called the orthocenter. The orthocenter. This is the last vocab word you need to learn before your quiz this week, okay? An orthocenter. So if you connect all of your altitudes, right, for this triangle in our diagram, you get to point G. G becomes your orthocenter. So in the last problem that we did, that point where all three of our altitudes intersected was the orthocenter. Now, what I want you guys to do is I want you to skip, okay, which is the graphing problem. For these types of problems, the only thing I'm going to ask you, and I need you to write this down, is you're going to have to tell me whether the orthocenter is inside, outside, or on the triangle. Okay? Inside, outside, or on the triangle. Now, how we figure that out is we have to figure out, okay, what kind of triangle is given to us. So go ahead and plot those 3 points and try to figure out what kind of triangle it is. Is it acute? Is it right? or is it obtuse? I'll give you guys a minute to do that right now. Okay, compare what you got with the person next to you. Tell me whether it's inside, outside, or on. Go. 5, 4, 3, 2, and 1. Who thinks they got it right? Bryson?
It's a right triangle and it's on.
Excellent. This one would be on the triangle because it's a right triangle. Guys, this is all I will be asking for you for an orthocenter. Are we clear on that? Now, if we want to take it one step further, this will not be asked of you. Does anyone know the actual point of the orthocenter? Cody?
Maybe -3 and 4.
-3, 4. How did Cody know that -3, 4 is the point of the orthocenter? Dougie? Very good. This is the point of the perpendicular angle. Very good, Dougie. Okay? Now, I will not ask you the actual coordinates of the orthocenter, okay? But you do need to be able to tell me whether it's inside, outside, or on the right triangle. Are we clear? What kind of triangle would cause the orthocenter to be inside of it? An acute triangle. What kind of triangle would cause the orthocenter to be outside? Obtuse. We Gucci? Any questions? All right, let's do this next slide and go to this slide, okay, where it says the location of the orthocenter depends on the type of triangle. So this point is very similar to the circumcenter. Do you guys remember the circumcenter? It had 3 possibilities of where it could lie. For an acute triangle, where was the circumcenter? Inside the triangle. Whoops, who said outside? Okay, it happens, okay? For an acute triangle, the circumcenter is always inside. Same thing for orthocenter. So go ahead and put a dot at P. And notice for an acute triangle, the orthocenter will always be inside that triangle. Okay? The altitudes will stay inside the triangle, so will the point of concurrency. Now, for a right triangle, where's the orthocenter? It's on the triangle. And specifically, it will always be the point where the 90 degrees happens. Okay? It will always be the point of that 90-degree vertex. Now, this is different than the circumcenter. Where did the circumcenter lie on a right triangle? On the hypotenuse. Okay? If you want to put a star next to this one, notice that difference. Circumcenter, always on the hypotenuse. Orthocenter will always be at the 90-degree angle, at the actual vertex. Okay? All right. And then lastly, when it's an obtuse triangle, P will be where? Outside. So do you see how this point P is outside the triangle? Remember, your triangle is the triangle in black, okay? If you want to highlight it or put a little extra stuff, there's a lot of lines going on here. The black triangle is our triangle, and it's obtuse. It has an angle that's larger than 90 degrees. Now, 2 of our points, the circumcenter and the orthocenter, can be inside, on, or outside. What are the 2 points that must always be inside the triangle? What are the 2 points that must always be inside the triangle? Yes? The in-center and? Not the circumcenter. The in-center and? What was the second one? We just learned it, yeah? The centroid. Very good, okay? So the next slide, problem that we see. One more practice. Back to this example. After we talk about, is the orthocenter always located in the interior of the triangle? No. Where else can it be? It can be outside. Or on the triangle. Okay? The incenter and the centroid are the only 2 points that always stay inside the triangle. Okay, now, okay? This is a summary of all 4 points of concurrency, what connects them, in other words, how you find them, what segments you need to draw, and what their properties are. AKA, this is your best friend. If you're going to make flashcards, this is the slide that you need to use, okay? Now, the orthocenter. Remember how I said like centroid has like a superpower? It's the center of gravity. Incenter is the same distance from all the sides of the triangle. The circumcenter is the same distance from all the vertices of the triangle, vertices of the triangle. Guys, the orthocenter has no special property, okay? It's just the intersection of all the altitudes, all right? So, what I want you guys to do is actually 2 slides. We're just gonna do 2 of these. We're gonna do number 23 and we're going to do number 24. Got it. We have to draw the indicated triangle and find both its centroid and its orthocenter. Please, guys, make sure that you're changing colors here so you don't get confusing. There's going to be a lot of lines on these triangles, okay? So let's start with number 23. We need to draw an isosceles right triangle. What are the properties of an isosceles right triangle? What does it need to have? Yep. 2 congruent sides. So go ahead and draw 2 congruent sides. Sides that are the same length. What else does it need to have? An isosceles right triangle. Yep. A right angle. So put a right angle there and draw your last side. Question though, could I make these 2 sides congruent?
No.
Why not, Zach?
That side's longer.
Why does it have to be longer? What is that side? What is this side, guys? The hypotenuse. And the hypotenuse is always longer. So, guys, only the 2 legs can be congruent. Make sure yours matches mine. Are we Gucci? Okay, now first thing, change your color and put a centroid in some other color. I'm going to use red. Okay, so we need to find the centroid. Who remembers what segments combine, what segments intersect to help us find the centroid? I know it was on Friday, yeah? No, that's for the circumcenter. What segments intersect to find the centroid? Yes? Very good, the medians, okay? So, what is a median then? It starts at the middle of the side and goes where? To an angle, okay? So, find the midpoint of each of the sides. Guys, it's going to be a rough approximation. It's not going to be perfect. So I would say the midpoint of this bottom side would be here. It may be different for yours. I would say this one would be here. And the midpoint maybe is up here. And you have to draw those midpoints to the opposite vertex inside the triangle. So take it from a midpoint to the opposite vertex inside the triangle. And if you did it remotely well, they'll all intersect at the same point. And we're going to label that point C for centroid. How did we do? Was it okay? Remember, we don't know the true midpoint, right? Unless we took out a ruler and actually measured it, okay? It's going to be off by a little bit. That's okay. But I want us understanding that it goes from a midpoint to the opposite vertex. Okay, now let's do the orthocenter. Change your color and write orthocenter. That's very difficult to see, isn't it? What kind of triangle is this? Okay. Right and isosceles. Where does the orthocenter? Cody?
On the right angle.
on the right angle. So it's going to be right here. Now, for this sake, I want us to get comfortable drawing the altitudes, okay? So I would like you to start with this side being your base, okay? And start at this point up here and draw a perpendicular line down to your base. Do you guys agree that it's just that side over on the left? Is that cool? Does everyone follow me with that perpendicular line? Sienna, no? So, like, this side is the bottom side. Do you agree? Make that your base. Start at that point up there. What would be the perpendicular line down to the base? Do you agree that it would just be that side? Now, turn your iPad. So now that left-hand side is now your base. Start at this point up here. It should be at the top of your figure now, and draw a line down to your base. Make sure that it's perpendicular. Do you see how those two lines are going to meet at the 90? And then do it one more time. Make the hypotenuse your base. Start at the top point and draw a perpendicular line down to your base. And all three of those lines should intersect at your orthocenter, which we'll call it O, and it's the angle where the 90 degrees happens. So what I want us to make sure that we are clear on is the difference between the orthocenter and the centroid. We see the difference, correct? The centroid is the combination, it's the intersection of all the medians. The orthocenter is the intersection of all the altitudes. What does scalene mean? None of the sides should be the same length. Good. So just draw a last side. Make sure none of the sides are the same length. Okay? Obtuse and scalene. Okay, so let's go ahead and find the centroid first. We're going to use red again for centroid. Let's find point C. Centroid, you have to find the midpoint of each of the sides, approximate it. I would say the midpoint's close to here. The midpoint here is close to here. And the midpoint here is close to here. It's roughly okay. And then connect it with the opposite vertex in your triangle. Man, I'm good. And this becomes your centroid. It does not have to be perfect, but if you're way off, try it again, okay? I see some people connecting the midpoints to each other. That is a different segment. We'll learn about that later. Your midpoint goes to the opposite vertex. Do not connect the midpoints, okay? So this is our centroid. The centroid will always be where? Inside. Very good. In the middle of the triangle, okay? What is the property of the centroid? What do I know this point is now? What was its superpower? It's the center of gravity, okay? So you could balance this triangle on a pencil as long as the pencil's tip was touching the point C, okay? All right, next we have to find the orthocenter. Now, what kind of triangle was this? Obtuse. So where should the orthocenter be? Outside. Now, what I want you to do is start with this bottom side as our base, and I want you to start up here at the top vertex. Draw a segment down your triangle, down to the base, must form a 90-degree angle with your base. Keep in mind, guys, this line is going to be outside the triangle. And draw it, make sure that it continues out. Guys, you'll notice if you continued your base out, right, you can better see how it's going to form a 90-degree angle. Then you're going to have to tilt your iPad. You're going to have to change its orientation, okay? I'm going to make that left-hand side my base now. And I'm going to start from this point over here on the right. And I'm going to do the same thing. I'm going to carry out my base this way. and draw the perpendicular line down to that base. You'll notice that those two lines intersect outside the triangle. Do you guys see that? And then you have to do the last side just for insurance to make sure that it also intersects down there. Turn it so that longest side across your triangle is now your base, and your starting point is right here. Then when you draw a perpendicular segment, it should look like this, right? But that stays inside the triangle. Continue it so it goes outside your triangle. And all three of those lines should intersect near the same point, which will be your orthocenter outside the triangle. Guys, this is the end of the notes, okay? Do not turn these in again.